Okay, so we've seen a lot of different types of machine screws and combinations of nuts and bolts, but what do we do when we have a situation where we're working inside of a closed form that we can't get to the inside of that space, but we want to be able to use a machine screw to make an attachment to hold something down to it. So if I wanted to secure this in place and I couldn't get inside to put the nut on the inside, either because my reach was limited or it was a closed form, then we do have options. And that option is that we're going to replace that nut with threads that we create in a hole, internal threads, that will, in essence, turn the thickness of the cross-section of our material into a nut so that we will have a good, secure connection between those parts and pieces. So that's done using what are called taps, which I have here. Taps can be, there are some taps that can be mounted into a device that's very much like a drill press that has what's called a tapping head on it that allows it to cut internal threads into pieces of material. But because we don't do this that often, we're usually tapping holes by hand. We're using the drill press to establish a precise hole in our material, because one of the benefits of a drill press is that it's able to articulate a precise perpendicular relationship all the way through our material without relying on us to keep that bit going straight like we would have to do with a hand drill. So drilling in advance of tapping is creating a pilot hole, like we talked about using pilot holes for wood screws and for sheet metal screws. That pilot hole wants to be equal to the body of that tap, so that just like with a wood screw or a sheet metal screw, the only thing actually cutting into our metal are the part that's creating these corresponding teeth cut into that material, creating the internal threads. So typically we drill on a drill press with a precision drill bit that's engineered specifically for this application. If you are just doing this for a very specific hole size, there's no need to invest in a set of taps. You can simply buy a tap and its corresponding drill bit in a little blister pack just like this. So it's going to tell you what the size is. It's going to tell you what the frequency of the occurrence of the threads are. So this is a 6 millimeter by 1.0 threads per millimeter. And it also requires a specialty bit to go along with that, because the specificity of that hole size is very particular when it comes to using taps. If the hole is even a fraction of an inch too large, the threads will not bite into the material properly. And if it's too tight, the tap will not have enough room to clear or cut away the material to create those internal threads. And here's a news flash for you. These taps are made out of a material that is extremely hard, and that's what gives it the capacity to cut, but it's also exceptionally brittle. So I can tell you that on many occasions I've seen people snap or shear taps off from not using them properly or for not having the proper size hole in their material, and once a tap shears off inside of a piece of metal, it's next to impossible to remove. There are some tricks that can be used, but it is a huge pain to try and remove a tap that snapped off inside. Anyway, Because the specificity of use is so particular, you'll find that it's very rare that there is a fractional drill bit that corresponds to a common tap size. It is more common that you will find that there is a numerically indexed drill bit that corresponds to that tap size. So, in the world of fractions, a drill bit kit like this might include everything from a 64th of an inch up to a 1/2 inch, stepping up in 64th of an inch increments. That is not precise enough for creating internal threads on a piece of material. Numerically indexed bits are, I don't even know what order of magnitude to use to describe it. There's probably at least a dozen bits that are of different size in between the two sizes that you would find in a standard fractional drill bit set. So it's very specific in terms of its application or use. So we have fractional drill bits, which are used by people in general. We have numerically indexed drill bits, which are used by machinists. And then there's this other indexing system that I don't even know why it's there, but it's an alphabetic indexing system that you'll find used for some taps. So, as I said, you can buy individual sets that includes the bit and the tap, or you have these tap index sets that come with a range of the most commonly used sizes. So in here you can see we have 632, that's national fine, and number 6, that uses a number 36 drill bit. And 832 uses a number 29, 1024, 25, 10/32, 21, quarter 20, number 7, 5/16, 18. Here comes that oddball alphabetic reference. That is an F drill bit. All right, let's see what we can do about wrapping up this module. So we looked at the different types of taps that are available, but I want to make a couple of distinctions. That most taps are right-handed. They also make left-handed taps for counterclockwise threads. This particular tap handle gives us a lot of leverage and control over a tap and can accommodate a wide range of sizes. Left is loose and right is tight to hold our tap in place. This is another style of tap handle that's called a T handle. It has a jawed chuck. And last but not least, I want to talk a little bit about thread forming dies. So if taps are for creating internal threads, dies are for creating external threads. So we're able to use that to cut external threads on the ends of pieces of rod. So thanks so much for taking the time to participate in Fastenation, and look forward to seeing you in the near future.